So we want to find the indicated measure for each of those circles. So for number 1, we're looking for the measure of angle BAC. Okay, so angle BAC, that's this angle right here. Right? Well, that angle intercepts this arc from B to C, which is 124. Okay, so what can I do with that 124 to find this angle? Divide it by 2. Okay, so I'm going to take 124 and divide it by 2. So that angle measure is 62 degrees. Okay, then in number 2, I'm trying to find the measure of arc RS. That's this arc right here. Okay, well this angle RQS intercepts that arc, and that angle is 22 degrees. So how can I find that intercepted arc? Multiply by 2. So that arc measure is 44. Okay, so remember you have those intercepted arcs and those inscribed angles. So we're going to look at one more theorem in this section here. Okay, so it states if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so there are 4 big vocabulary words here, and we're just going to redefine those. So quadrilateral, how many sides does that have?
4.
Good job, Isaiah. I'm proud of you.
Okay, so if you have a 4-sided polygon that is inscribed, okay, what does inscribed mean? Think about it. If I say something's inscribed, it's on the inside. So that would mean inside a circle. Okay, so it's inside that circle. Then it's opposite angles. So those are your angles not next to. Or your angles that are across from each other. Okay, are supplementary. What does supplementary mean? Add to 180. Okay, so if you have a 4-sided figure that is inside of a circle, then the angles that are across from each other have to add to 180. Okay, so that's what this theorem is saying. So we're going to do some examples. These first 2 here are not quadrilaterals. Okay, they are triangles inscribed in a circle. Okay, so we're not looking for angles across from each other to be supplementary yet. We will get into that. But first, I'm going to do a couple examples with these triangles. So number 1, we want to solve for x. Okay, so I have W is x plus 12, and angle x is x degrees. Okay, what do I know about all 3 angles in a triangle? They add up to 180. So first, what I want to do is see if I can find what this angle y is. Okay? Well, if I look at that arc from W to x, what degree measure is that? 180. Okay, so that arc from W to x is 180 because this line right here is a diameter and it is 180 degrees, right? Well, if this angle y right here intercepts that arc, and that arc's 180, what does angle y have to be? We just worked with an inscribed angle up at the top. It is 90. Okay, so to get that angle, I take that intercepted arc of 180, divide it by 2. That angle is 90. So now, to solve for x, I'm just going to add all 3 of my angles together and set them equal to what?
180.
180. Okay, so all 3 of my angles, add them together, set equal to 180. So I have 2x plus 102 equals 180. Subtract 102 from both sides. Then divide both sides by 2. X is equal to 39.
And then do 39 plus W.
Yes. So then I also want to find the measure of angle W. That's this angle here. Well, I already know what X is, so I'm going to plug in 39 for X. So we have 39 plus 12. So the measure of angle W would be 51 degrees. Okay, questions on how I solved for X or how I found angle W?
Nope.
All right, do numbers 3 and 4. So use that picture off to the right there. Numbers 3 and 4. All right, so looking at 3 and 4. So number 3, you had to solve for X just like we had to do in number 1. So first thing I see when I look at this picture is that I have a triangle inside a circle. And I know all 3 angles of my triangle have to add to 180. So that means I want to find what angle S is. Well, if I look at my arc from R to T, that arc is 180. Okay, it's half of a circle, right? Half a circle is 180 degrees. Then that angle that intercepts that arc is half of that measure, so that angle again has to be 90 degrees. Okay, so I can add up all 3 of my angles. 2x plus 4x minus 6 plus 90 has to equal 180. So I have 6x plus 84 equals 180. Subtract 84 from both sides of your equation to get 6x equals 96. Then divide both sides by 6. And x is equal to 16. Okay, then in number 4, you are solving for the measure of angle T. So since I know what x is now, I can just plug in 16 for x. So I have 4 times 16 minus 6. And you do end up getting the measure of angle T is equal to 58 degrees. Okay? So when you see a triangle inscribed in that circle, you do want to make sure you find all 3 of those angle measures. Okay? So if you're missing one of them, look at the arc that's intercepted by that angle. Okay? To see if you can find that angle measure. Okay, are we good? All right, then we're going to look at the next side here. This is where we're going to use that theorem that I talked about on the front. Okay, so you have a 4-sided figure within a circle, so its opposite angles are supplementary. So for numbers 5 and 6, we're using this circle here, and we want to find the measure of angle R and the measure of angle S. Well, to do that, I need to know what x is. Okay, so since I do have a 4-sided figure, that means my sides across from each other, okay, opposite angles are across from each other, are supplementary. So I'm just going to use this angle here, 110, and 2x. So those two are across from each other. So I can add them together. So I have 110 plus 2x. That has to be 180. Okay, so from here I'm just going to solve for x. So I'm subtracting 110 from both sides of my equation. So I have 2x equals 70. Divide by 2. Okay, x is 35. Okay, since x is 35, now I can solve for the measure of angle R and the measure of angle S. Okay, so for R is 3x. So I'm just going to plug in 35 for x. So we have 3 times 35. It's 105 degrees. And for the measure of angle S, again, plug in 35 for x. So we have 2 times 35. That's 70 degrees. Okay, so when you see these 4-sided figures, you do need to set those opposite angles equal to 180, not each other. Okay, so they are not equal to each other. You have to add them and set them equal to 180. Okay, in years past, people tend to get these problems wrong because they set them equal to each other and they are not equal to each other. Okay, so pay attention to that. I want you guys to do 7 and 8. For this one, you have to solve for both x and y. Okay, in order to find angle W and then angle X, you need to solve for y. So I want you to do those 2 problems using that circle on the right.
Oh.
What?
Is it decimals?
Yeah. Yeah.
Is it decimals?
No,
It's the same thing for
they're not equal. Did you set them equal?
No.
You added them and set them equal to 180?
Yeah. So the same as for usually. So
You get the second one? All right, so for 7 and 8, again, your opposite angles, so those are your angles across from each other, have to be supplementary because this is a four-sided polygon, okay, within a circle. So first, to get W, I need to get X. So I'm going to take those two angles that are across from each other, and I'm going to add them together, set it equal to 180. Again, do not set them equal to each other. Okay, they're not equal to each other. So we have 3x plus 18 is equal to 180. Subtract 18 from both sides of my equation to get 3x is equal to 162. Divide both sides by 3. So x equals 54. So to get angle W, I'm going to plug in 54 for x. So we have 54 plus 18. That's 72 degrees. Okay, then for angle X, we have to first solve for Y. So again, those two angles across from each other add to 180. So we have 3y minus 7 plus 3y plus 1 is equal to 180. So combine like terms, we have 6y minus 6 equals 180. Add 6 to both sides of your equation. So we have 6y equals 186. Divide both sides by 6. Y is equal to 31. Okay, so now that I've solved for y, I can find the measure of angle x, which is right here. I'll plug in 31 for my y value. So we have 3 times 31 minus 7. That's 86 degrees. Okay, questions on how I set up or solved those two problems? Okay, then the last problem on the bottom is a writing question. It says compare and contrast inscribed angles and central angles of a circle. If they intercept the same arc, how are they related? So first thing, before you write anything down, I do want you to turn to the person next to you or sitting near you and talk about the difference between an inscribed angle and a central angle. Okay, so what's their difference? What do they look like in your circle? An inscribed angle and a central angle. Okay, so talk about those. No. I don't. I have hand sanitizer.
And do you approve of your girlfriend Sheila? Yes, the best friend? Mm-hmm. Your favorite best friend? Married yesterday or something?
Oh, Sheila has lotion if you need lotion.
Yeah, lotion.
Hand sanitizer, that makes me feel good, which doesn't make me feel good.
All right, so I'm going to write out this answer. So first thing I'm going to look at is the inscribed angle. So an inscribed angle has its vertex. So that's where the angle is. Okay, so again, the vertex is that angle part. Okay, that vertex is on the circle. Okay, so that's an inscribed angle. Then a central angle. Okay, a central angle has its vertex at the center of the circle. Okay, so I just described what was different between those two. Okay, so inscribed angle, vertex is on the circle, central angle is from the center. Okay, then if they intercept the same arc, how are they related? Okay, so if an inscribed angle and a central angle. Okay, so I'm just starting off my sentence about what I was asking. So if an inscribed angle and a central angle intercept the same arc, then the measure, let's say the measure of the central angle is double the measure of the inscribed angle. Okay, so remember when they're intercepting the same arc, if you need to redraw a picture of what that means, okay, that's if you have your circle, right? Your central angle is from the center. Okay, that would be a central angle. Okay, your inscribed angle is on the circle. So in this case, this is where they intercept this same arc right here. Okay, so that's what that second part of this question was talking about. So how are they related? So I said the measure of the central angle, that's this one, has to be double the measure of that inscribed angle. Okay, because for this inscribed angle, if you knew that measure, you double it to get the arc measure, which is the same as the central angle measure. Okay, so you can just say that it's double that measure. Okay, so if it helps when you're doing these questions to actually draw out that picture, make sure you draw out